Well, now we have to train it automatically. So guys, let's start. If we want to work with the AND operation, we have four training example, right? So it is like this. This is negative, 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 and positive class. And we have three weights. That is W0, W1, W2, X0, that is 1, X1, and X2, and output here. So the one that we have to do is, the rule is quite simple. This is a training rules. I think we have not enough time to find it or to prove the rules, the training rules, but you can use it, simply use it. If summation of I is 0 to n, Wixi is less than 0 and class is positive. What does it mean? It means that it is wrong, right? Because the summation is less than 0, but the class is positive. We need to this summation to be greater than 0, right? Okay, so you can adjust the weight. Wi is Wi plus learning rate, or you can think that this one is, we call it eta x. Okay, else if the summation is greater than 0 but the class is negative, you have to adjust the weight by minus eta and x. Else, no need to do. Nothing to do. Because if in other cases w.x or summation of Wixi is greater than 0 and class is positive, and the other cases is summation of I is 0 to n Wixi is greater than 0 and class is positive. That is correct. Okay, else do nothing. Okay, this one is the training rules. Okay, this is the training rules. Okay, it's very important, so I'd like to make it, you have to I would like to highlight it. This is training rules. Okay, for the first kind of perceptron, the one that use the threshold and check that if it's greater than 0 it will be 1. If not, if it's less than 0 it will be 0. It will be not negative class. So let's I will trace this algorithm in a spreadsheet so you can see the steps and you can understand it easier. Okay, this one is the training rules of the first kind of perceptron. Okay, Okay, so we will start with the weight. That is like when you have when you have x0 is 1, always 1, x1 and x2, 0, 1, 1, 0, and 1, 1. The one that you want, we will use the target values. That is, we use the term target to represent that this is negative, 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 and positive. And for example, we have the weight like this. We can start with something that is a small constant. Can be positive or negative. And if you sum all of them together, this one, summation of w and x, wi, xi for all I, it becomes 0.1, right? 1 times 0.1, 0 times 0 times this, so all of them is 0, 0, 0 plus 0.1. So w dot x, or summation of wixi is 0.1. So the output will be 1 because it's greater than 1, right? So in this case, you may use 0, 0, 0, 1. That's fine. The negative class is 0 and the positive is 1. So you can see that now in this case, the target is 0. W summation of wixi is greater than 1, right? But the target is 0. So what you have to do? The summation is greater than 0 here, greater than 0, and the class is negative. So minus learning rate times x. So you have to use the learning rate times xi and deduct it from wi. So for example, if the learning rate in this case, if the learning rate eta is 0.2, for example, you have to times 0.2 to all x here. That actually, if the case that x is 0, you cannot adjust the weight w. But in the case that you can adjust like this, learning rate 0.2, 0.2 here times 1. So this term will be wi is wi minus 0.2 and xi. In this case, xi is 1, right? That is for 0 for x0. So w for w0 in this case, I is 0. So wi will be, w0 will be 0.1 minus 0.2. So this becomes 0 minus 0.1. And because x is 0 and 0, so when you times x to the learning rate, it becomes 0. So wi will still same. So you get this one. Okay. And once you find summation of this term, 1 times 0 minus 0.1, 0 times this, so it will be 0. And how about this? Can you see? Now, the summation is 0. Exact 0. But actually, like the one that I always said, we don't want it to be 0, right? So you can make it like it's incorrect. It's incorrect. The target is 0 and the output is 0. Actually, you can think that it is 0. So you don't. In my case, I would like to adjust the weight. So which case to be used. You can think that if in the case that you don't want to be 0, you can use this symbol also. So in the case that is 0, you have to adjust. So if the target is the class negative, and it means that now you want to adjust it. So again, I will write here W0 will be W0 minus learning rate times x. This is x0 must be 1, right? So it will be minus 0.1 minus 0.2. So this will be minus 0.3. And how about W1? W1 will be W1 minus 0. And this one, x1 is 0, right? So it will be 0 here. So W1 will be same. So it's still 0.1. And how about W2? How about W2? W2 is W2 minus 0.2 times x2. In this case, x2 is 1, right? So x2 is 1. So W2 will be 0.1 minus 0.2. So it will be minus 0.1. Okay. And the summation in this case, minus 0.3 times 1, right? Is, is 0.3. 0.1 times 1, it will be 0.1. So this one is 0, so we cannot count it, so it will be 0. So in this case, it is minus 0.2. That is, this output is 0. So maybe you can mark it like, okay, we don't like this kind of output for the second one. For the third one, this one will be 0. That's correct. So if it's correct, just leave it like that. Then you can go to the next step. Okay, guys, let's go back to our computer and I'll show you in the spreadsheet how can we train the perceptron in this case.